Welcome back to my YouTube channel at mga palangga ha. Nakakaloka. Wow! Okay, so we have now welcome back to my YouTube channel mga palangga. Welcome back. This is again I'm a singer tone voice. Okay, oh my gosh. Like that. Okay? Klaro na ba? Okay. Sige. So we have problem number 2, right? Okay. Problem number 2. Okay. 40 grams of calcium chloride. And then what's this? Is dissolved. Is dissolved. What's that? In 600 ml of water is 600 ml of water. Okay. What's this, guys? At 25 degrees Celsius. Nakakaloka. What is the vapor pressure of solute in the solution? Okay, what is the vapor pressure of solute in the solution? Then, with vapor pressure of pure solvent, actually this is pure solvent in situation like this. Oh, okay, 23.8 Tor at 25 degrees Celsius. Okay, C. And then we have the density for sure. Okay, and density, can I make temperature? And density is 1 grams per ml. Okay? So take note, the problem is very clear. Okay, clear siya. Pero it's gonna be tricky, right? So 40 grams calcium chloride is dissolved in 600 ml of water at 25 degrees Celsius. What vapor pressure solute in the solution? The first tricky part here, actually guys, this is Chemical Engineers Board Examination 1993, November 1993. Okay, in the Philippines. Okay, so the gray area in this particular problem, gray meaning G-R-E-Y, not the gray, G-R-A-Y. Okay, not the color. Use the vague part, the confusing part. Okay, or the tricky part. Okay, so we have two issues here. First is the calcium chloride. So that is the first confusion of the students or professionals, should we say. Because me also, I'm confused. Okay, and then number 2, issue is the vapor pressure of solute in the solution. Okay. Vapor pressure of solute in the solution. Okay? Of the solution. These are the two issues. The first issue, guys, is this is an ionic compound. Okay? This is an ionic compound and this is not a molecular compound. Okay, you get the point because it's a metal plus a non-metal. Okay, you get the point. And then this calcium is a metal, chloride or chlorine is a non-metal. Okay, this is the first thing. And now, since this vapor pressure lowering of the solution involves the number of moles in the computation of your solute, right? And then, so if you try to compute the number of moles here, we are not referring to the chemical reaction. Okay? You get the point? We are not referring to the chemical reaction overall, but we are referring to the dissociation of the ions. Okay? I'll teach you for this because, for example, this is if chemical reaction and then we introduce water, right? So calcium chloride plus water. Your product will be, this is a double displacement or double replacement chemical reaction. So your answer will be HCl, hydrochloric acid, plus calcium hydroxide, in which this is a hydrolysis chemical reaction, adding salt and a water. Okay, calcium chloride is a salt, definitely. If you speak about chloride, that is a family of salt. Not only sulfates, phosphates, but also chlorides, fluorides, the halide group. The halide group, okay, if banded to another compound, or shall we say element, it will yield salt. Okay, fluoride, chloride, bromide, okay, iodide, astatine. Okay, this is 7A family in the group of the periodic table. Okay, salt plus water is equals to acid and a base. And our acid is a strong acid, hydrochloric acid, and this weak base. Not really that strong, okay, weak base. Okay, compared to sodium hydroxide. This is calcium hydroxide. Okay, now you can see it's totally different because if you balance this chemical reaction, it's another story. We will produce another story of the number of moles. Another story talaga. Okay, so we are not concentrating here for the chemical reaction, but for the dissociation. Okay, when this calcium chloride dissociates into the water, since this is an electrolyte, we need to determine the ionization of the ions or dissociation. It will become calcium positive 2 plus chloride negative, and then times 2. Okay, you get the point? Ganon. Muna siya may tabo ng mga palangga. Okay? It's not the same when you balance the chemical reaction here. Okay? We will just be lucky if the calcium chloride here will equal also to the total of ions here. But remember, vapor pressure lowering of the solution is a colligative property. We need to remember that. That's why I told you, the theory will dominate the concept rather than the formula and how you solve it correctly. It's really the theory will matter. Okay, because if you try to solve this also accurately in terms of the chemical reaction, there's another answer to that. Okay, but you solve it perfectly as the way it is. But it doesn't match to the theory and the principles. We will go first to match the principle, the theory, and concept. We will not deviate. Okay, like that. So here will yield 3 moles of calcium chloride ions. Guys, when you speak about ions, guys, it really charged na talaga when we introduce water and solvent to become an aqueous solution. Okay? That's ions. That's not the same with number of moles or atoms or molecules. Okay? For example, positively charged ions and negatively charged ions, meaning to say cations plus anions. Okay? They are all ions. So if the compound will yield an ions, automatically they are ionic compound and a salt. Okay, that's very clear. Okay, we forget this chemical reaction, even though we balance this perfectly. Okay, so most students will still use these chemical reactions. Or the other version in which we will not involve the chemical reaction. For example, okay, calcium chloride. If we have the grams of the calcium chloride, we can also compute the number of moles directly without chemical reaction, without dissociation. So these 3 areas made the students confused. That's why the instructors will teach very well what is the appropriate method in determining the number of moles, because this is the mole of solute that we will be able to use that to plug in and to incorporate or substitute in our standard formula, which is the mole fraction of solute converted to the mole fraction of solvent. Get the point? Maugid din siya guys ang perming sa'yo. Okay? Including me before. Ako din na siya di-clarify. Okay? Ako siya di-clarify but I'm already a licensed chemical engineer. Knowing this, imagine. Okay? So it's not on my student time. We already graduated. It's gonna be like that. But before I don't got this. Something like that. oh, if I got this before, maybe, blah, 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 so on. So my grades will be that high enough compared as before in the past. Okay, so as I continuously research, okay, like that. Imagine for 5 years, okay, but then, oh my gosh, just now discovered. So meaning to say, if you try really to dig it out, the detailed study, so it will take you a longer years, more than 5 years to understand everything about math and science. The way how you derive, the way how you understand the principles, the concepts, the theories, the scientists, the scientific laws, the scientific research, and everything. So it needs a lot of years, several years. That's why the scientists studied too much, right? In the 17th century, 18th century, 19th century. That's the reason also. Okay, in fact, we are not scientists. How much more if we are really a scientist? Okay, like that. So going back, and that's the first issue. Okay, we will use the number of moles through dissociation. Okay, not the chemical reaction, not the balanced chemical reaction, nor not the moles in the linking the molecular weight. Okay, so that is the more mistakes, including me before. Okay, now second, vapor pressure in the solute of the solution. Vapor pressure of the solute in the solution. Now, because we are very, very eager to solve, especially me when I was young, when I was, let's say, first year college, we are very, very eager to solve, and we forgot to scrutinize, examine the terminology word by word. Actually, this is not referring to the vapor pressure of the solution. It's referring to the vapor pressure of the solute. Okay? Solute is not the solution. Solute nor is not a solvent. So it's different. Since we already know that the solution is there in the last sentence, we automatically use it as the vapor pressure of the solution without thinking that it's still solute. Meaning to say, we need to read the complete sentence to understand what is being asked. Okay? Because we are normally also solved in that way in our sample problems. This is the contributory factor. Why we will interpret that all the time that it is the vapor pressure of the solution, but actually it's not already. Okay? Because all the time this is the sample problem of the instructor. Sample mo naman like that. Every time. Okay? And then in the examination, also the same thing. I mean, they varied a little bit or changed and modified something like that. And then in the future, it will be rephrased, the paragraph or the sentence in the question. And then of course, since we normally met that for the first time, not the same as the method, the way how it is phrased when we are in our classroom instruction, normally we get panic because that is not the way how it is phrased in the sentence. You get the point? So we will still use in that way how the example problems being presented, and this is also the most errors and mistakes by examiners in the board examination. They always pattern in the same way how it is being solved during the sample problems discussion in the classroom instruction. But actually, there will be modifications there. That's why we need to dig really and extract properly what is really meant for that particular problem. We need to say scrutinize everything, okay, from the grammar, okay, because it matters, okay, especially the preposition and that, from, to, with, something like that. It will vary, especially in thermodynamics, it will vary, the sign will vary. For example, the work done by the system, the work done on the system, the work done on the system is positive, something like that. Example only for the sake of the conversation. Work done by the system is negative. Imagine, very big difference. The sign matters a lot in thermodynamics, something like that. So we need to understand the preposition on, by, from, to, where, but, like that. And also take note the comma, because the comma separates the thought or the impact of your sentence. Okay, so that's why I told you every time, if you're really good in English communication language, it will be an advantage because the sentences or paragraphs in the examinations in the future, especially board examination, are expressed in English. Okay, if you have a strong background in English, sentencing phrasing, grammar, terminology, vocabulary, and everything, then you can interpret well and you can analyze well also, of course. Okay? You get the point. Then plus, if you are good in math with higher IQ in numbers, then bingo, you have a very high scores in general engineering. Because all math falls in general engineering. Okay? Like that. So be careful. So here, vapor pressure when solid is being asked is not the solution. Okay, that's very clear. But in the qualitative property, the formula and standard formula given there is vapor pressure of the solution. So this is gonna be the a modification already. You get the point? So that's the two confusion part and tricky part before we proceed the problem. And the instructor must emphasize this. Okay, so that the students will understand. Why? While they are still in their lower level as their foundation. Okay, something like that. Okay, so we proceed now for the solution proper mga palangga. Okay, we proceed na ha. Okay. So I emphasize on me. Okay. Muna sinetabo. So this is vapor pressure lowering under the qualitative property. And then in the theory and concept also, again, this is not discussed also in the I'm teaching you guys areas in which I did not discover when I was in college. Meaning to say, I'm struggling a bit. Know that you're very struggling. It's a bit lang siya, 80%, 70%. It's not really totally 90% up. Because I cannot understand very well. Especially, not all, disclaimer, not all, because some also are good in discussion also. We cannot summarize all, but there's few who are very fast in discussion, and after one sample problem, after reading the paragraph in the introduction, they will not emphasize the theory, and the principal will immediately get the sample problem. Okay, and then, hala, did it so like this? Okay, so they did not emphasize very well how it is being explained well. They go directly with the formula. And in fact, the student also don't know how it is being arrived. Why did it become like that? And then the students have no right to ask. Because it's already in the whiteboard. You get the point? Something like that. And then after the session of the class, and that's the time the student will research the library, talking with another, classmates, and then because normally we will be ashamed to talk with the instructors if the instructors are very old. Not very old, older than us, not on the same level. Okay? Really, if you can relate that also. Okay? And then most of them also, since they are very experienced people, they are very mature. Then you cannot talk to them as easy as you could, especially you are young, right? The leveling of the age range. You could normally approach certain instructors that belong to your, age range, something like that. Or let us say the younger instructors. But actually, it depends on the situation, but I'm talking to the general, okay? Like that, okay? So, muna siya metabo. Muna lang siya iluom, okay? Because, sito kayo yung instruit. O, doon lang ka sa library. O, ito, kasi panikamot na lang ito imuha. O, ganon. Diba? It's gonna be like that. So, vapor pressure lowering of the solution is equal to the vapor pressure of the solution. Okay. Klaro ba whiteboard? Vapor pressure of the solution is equal to the mole fraction of solvent, which is the solvent here is basically the water. Okay, yes, water. So water times the vapor pressure of solvent. Okay, like that. Vapor pressure of the solvent. Okay, then one small circle at the top, meaning vapor pressure. Okay, like this is our equation 1. Okay, like that. Okay, now we need to determine the mole fraction of water. Okay, it's very easy because we have the properties of water here, the data of water here is mentioned. Okay, we have the density of water, 1 gram per ml at 25 degrees Celsius, right? So since we have the density, we could normally relate that to the mass and the volume. Okay? Put that in your brain cells all the time. If we have the density, we can link that all the time with mass and the volume because by common sense, it is the formula of density. Okay, the mass is in the top and the volume is in the denominator. Okay, so density of water. Density of water is equal to the mass of water, okay, divided by the volume of water. Now investigate one by one, quantity per quantity. Okay, density of water 1 grams per ml, then substitute 1 gram per ml. The mass of water. Okay, so you should be patient that you are after to the mole fraction. Okay, mole fraction, the word MOLE. So it has to do something with the mole. Again, as discussed previously, if we talk about the mole, automatic by default, just like a computer, you will link that always with the molecular mass or the molecular weight, right? And then link that with the mass also. It always like that all the time. That's why we are solving for the mass for the density of water. Okay, because we cannot get the number of moles to correlate it without the mass of the water, which is a requirement to solve the number of moles of water. You get the point? Something like that. Okay, the number of moles of water which is unknown, so you have to put question mark. Oh, ganon. Because we need to find out that one. Okay, so the mass of water is unknown and then over or divided by the volume of water. So it's specified in the problem the volume of water, so let's check. Okay, it's 600 ml of water is being mentioned in our problem, so you have to plug in our formula of density. So it's gonna be 600 ml. Okay, crisscross multiplication by math. Okay, we can obtain mass of water is equal to the density of water, which is 1 gram per ml, multiplied by 600 milliliters of water. By visual inspection, milliliters will be cancelled automatically. What's left is the gram, which is the unit of measurement of mass. Okay, so we can say mass of water is equal to 600 grams. So basically, the mass of water will just be equal to the volume of water at standard temperature, or shall we say 25 degrees Celsius, because it's always 1. Okay? There's no effect. You can also memorize in that way. Density is 1 gram per ml. No need to compute like this, especially you memorize already. I'm just showing this because this is only discussion. But when you are facing the examination in the future, to save time, especially the density of water is at standard temperature, then equate that to 1 gram per ml. No need to solve that by using density, mass over volume. Have a theory in your brain cells that the mass of the water is also equal to the volume of water at 1 gram per ml density, because 1, it doesn't matter. Okay? Anything multiplied by 1 is always the same thing, the number you multiply. You get the point? If I would say 2.85 million times 1 is always 2.85. That's why you need to memorize na lang talaga siya. If your density is always 1 at standard temperature. Because sometimes in the problem also, it's not standard temperature, whatever, it's not 1. There's another temperature there. For example, here, 23.4 degrees Celsius, and the density is not given. So you have to look for the tables in the indexes of the physics book, chemistry book, or you can Google search that in the www World Wide Web in the internet, so that you can get also the density of water at 23.4 degrees Celsius. That would also another value will come out. This is only good because it's standard temperature. Okay, that's 1. It will change also in the future. And sometimes also you need to interpolate. Okay, if the desired density and the temperature mentioned in the problem is not there. For example, it's in the middle, your interpolation will do. Okay? I will teach you how to interpolate later. But it depends on the problem kasi it's difficult to fabricate problem by our own brain cells. Usually we need to refer the references. Okay, I can only manage if the topic is not very difficult or complicated. Normality, molarity, you can make your own, you can make your own question, okay, during the discussion. But in here, I cannot, right? Okay, I have to have more time to develop and create and to author ba tawag yan? Okay, problem. Okay, like that. So we have the mass of the water 600 gram. Now correlate that to the molecular what mass so that you can compute for the number of moles of water. Okay, like that. Now guys, since water is an additive and a solvent, no need to consider the dissociation of water. Not the same as calcium chloride, ha? Okay, so again, in the computation of the number of moles of water, no need to dissociate that one because it is a solvent, not a salt. Okay, that's also a theory. Okay? You got a point mga palangga. So, ditso ka, if you have the grams, correlate that with the molecular weight. Find the number of moles. So, I say 600 grams of water times the molecular weight of water is 18.016 gram per gram mole. Okay, as early as now, memorize na mga palangga. Kay water na siya, guys. Okay, very common in our day-to-day life. Okay, get the point? Substances that are common in our day-to-day life, you can memorize. For example, sugar, salt, hydrochloric acid, okay, alcohol, ethanol or methanol, like that. Or you can also memorize acetone if you want. Acetone, okay? Ketone family in organic chemistry. Okay, but just memorize the basic, for example, the water, the salt, the sugar, the air. Okay, I'll teach you. The molecular weight of air is 29 per grams per gram mole. So no need to look to the book, no need to look to the Google search. Put that in your brain cells that the molecular weight of an air, which is composed mainly of nitrogen gas and oxygen gas, is 29 grams per gram mole. Then, if you can put that in your hippocampus part of your brain cells, then by the time you will get old, it will stuck in your brain cells, and you will never forget that until your last breath. You get the point? Provided that you really love science. In my case, because science is my favorite subject, that's why usually when I memorize, when I understand, I memorize, then it will be engraved into my brain cells as I grow older, something like that. Okay, so that's the difference. If you don't love that thing, then of course it will not be engraved in your brain cells. You are only forced. Then after 3 months, 4 months, 6 months, it will be disappearing. It will vanish. It will disappear because you don't love. Okay, you got the point. So if you love that thing, it can accumulate. Okay, to the end power, something like that. Or as you grow older, ganon. Okay, now moles of water is equals to 600 divided into 0.16. Okay, like that. So as you continue solving different problems, and it helps you also to review certain topics in chemistry, right? In which, I forgot this before. And then it will just automatically flash back without referring the books, the Google search. And the Google search only and the books are just only the proving material only. You know, if you forgot a little bit, just search the Google search. But the main point are already engraved in your brain cells. The purpose of the Google search only, the books are only for the review and only for you prove it if it is correct or not. But the extraction of the knowledge is accumulating in your brain. You get the point? Okay. Unless you don't know everything, you have to Google search. Okay, you get the point? Okay. Or unless it is not your masterpiece and it is not also your expertise, then you will also refer all the time to the Google search. Or it is not your specialization in the first place, then you have to acknowledge the Google search. Okay, but if that is really your line of specialization, then you will only add, review, confirm if you forgot or not. You got the point? Something like that. Because that is your profession. Okay. You get the point mga palabas. 600 divided by 18.016. Okay, 33.30, right? Maginetabo. Again, review 600 divided by 18.016 mga palangga. 33.30. Nakakaloka. So 33.30 moles of water. Ganon. Okay? Now, mole fraction of solvent mga palangga. Okay, mole fraction of solvent, water. So how can we compute this one? So X is the symbol of mole fraction. Okay, so we have the moles of water, okay, H2O, over N siya guys, hindi siya N. Okay, moles man siya. So moles of water plus moles of water plus moles of calcium chloride in ions dissociation. Okay, now the moles of water is being computed already, 33.30 moles, and then over again the moles of water, 33.30 moles. Your problem now will be now the moles of calcium chloride. You don't know yet, question mark. Take ganon. Now compute for the number of moles of calcium chloride. Now we go to the dissociation directly. Okay? To understand further. Okay, we have. If you introduce this salt in the water, what will happen? It will dissociate into calcium and chlorine gas. Something like that, okay? Chloride na siya because it become charged. Not chlorine. Okay? So calcium chloride like this. It will become calcium positive 2 plus chloride negative 1, then 2. Okay? Like that. Okay? You get the point mga palangga? Okay. Take note. Some also students will put still the chlorine gas in the dissociation. It's wrong. Because this is not a chemical reaction. This is only dissociation through water. Okay? Because calcium chloride is an electrolyte, is a salt, something like that. And our topic is a colligative property in which we need to determine the concentration of the solute molecules or ions. Molecules and ions are partly the same talaga siya. Okay? You get the point? Okay, like this. So you not put chlorine gas, huh? Because the chemical reaction of this gas is like this. If we don't refer to this topic, calcium chlorine is equals to calcium plus chlorine gas. And in balance, chupa-chuchu, put 2 here, and then balance, perfectly balanced. So calcium chloride will produce calcium solid plus chlorine gas. When you decompose calcium chloride solid, for example, if you will be able to heat that at a high temperature, this calcium chloride solid will split into a calcium solid and then just like a precipitate, a solidified substance, plus the chlorine gas. But your chlorine gas will vaporize into the atmosphere because chlorine gas will evaporate. Okay, because that's gas normally by its nature. So this is different. Not the same with the dissociation chemical reaction we will introduce to water. It will become calcium positive 2 plus 2 moles of chloride. It's very different. So if your theory is not wrong, is not matching, you will use this chemical reaction, you will wrong automatically because your number of moles of calcium chloride here in the chemical reaction in the decomposition is only 1. But this, you will use this one, it will become wrong. It's not 1. Okay? So, your total ions will be used in calcium chloride for computation of the number of moles is, okay, listen very carefully. Okay, 1 mole of calcium chloride, 1, ganon, plus 2 moles of calcium chloride. So, 1 plus 2 is equals to 3. 1 mole of the calcium, 2 moles of the chloride. Okay. If we are very, very clear that the moles are being added. Okay, again, the moles are being added, not the charge. Okay? Because the charge here is positive 2 for calcium, negative 1 for chlorine. Right? Something like that. Okay? And then we know also very clearly that the number of moles are just equal to the coefficient, meaning the number put beside the element and the compound, and that is known as coefficient equal to the number of moles. Okay? And that's very clear. Any questions so far mga palangga? Okay. So we have that the number of moles is 3 moles. Now, these 3 moles here will be used now. Okay? 3 moles will be used now. Okay. Now, you will not also substitute these 3 moles immediately. So there's a lot of confusion in this topic really guys. I'm struggling for this when I was in college really. This is the Raoults law. Okay, Raoults law and the vapor pressure lowering. And it was very sad. It really came out in the board examination. I think there are at least 2 or 3 something like this. Okay? And I'm very sad. I know all the formulas regarding this, but only the how it is being analyzed well at the time. Because the way it is being taught is not really that, what shall we say, comprehensive. That's why we need to go to the library to understand more. It's totally different if your instructor discusses that already comprehensively. Because you don't need to input more by doing your own initiative, going to the library, going to your own self-study. If the instructor can deliver very good discussion of that particular topic. But it happens at that time, I don't want to mention, okay? Muna siya natabo. Okay, it's not good also to specify, right? Okay, so, like that. So, muna siya guys. These 3 moles, mabitik na kung ka. Naman kay mole fraction of solvent. Imo sa next subject din yung isa na bro, moles of calcium chloride. It is not yet also. Okay, go with the 40 grams of calcium chloride first. Or else, your 40 grams of calcium chloride is not affecting your solute or solution. If you will use this automatically 3 moles in your computation of the mole fraction. That's why some students will got mistakes also. Because if they see that this is already a mole, they will substitute directly in the computation of the mole fraction. Then what's the use of the 40 grams of calcium chloride in the problem? Right? There's a purpose for that. And don't be in hurry in solving this kind of problem because it needs scrutinization, or thorough examination on, the topic to topic, term to term, something like that. Okay? Now, use this 40 grams of calcium chloride to determine the total number of ions of calcium chloride molecules of solute. So, this 3 is not yet. Okay? Okay, start with 14 grams. So 14 grams of calcium chloride, we use now the dimensional analysis conversion way of solving. Meaning to say, we don't refer to the standard formulas and standard equations. We need to use the longhand computation based on the proportionality, based on the conversion, blah, 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 chuba, chu, like that, everything. Okay, so 40 grams of calcium chloride, and then link again that to the molar mass. Okay, a trillion of times I always explain in this way. Link that in the molar mass and molecular weight. If you have the gram, if you have the number of moles, then bingo. The rest will follow. Okay, so 40 grams calcium chloride. Okay, what is the molecular weight of calcium chloride? I cannot memorize. But I am sure the atomic weight of chlorine is 35.45 grams per mole. Okay, but I don't know with calcium. I think it's gonna be... before I memorize the common kasi, I think it's gonna be 40 point something. Let's check in the periodic table. You said in the whiteboard. Okay, because our memory fails. Like it's a calcium. Nasaan ka? La? Yes, perfect. It's 40 point something. So, napipilit ko siya kung brain cells. Okay, so 40 grams. Okay. 40 grams per atom. Okay. Plus 2 times 35.45. Okay, like that. Okay. Guys, my purpose of the discussion is not that always all the time that you have to be perfect in the in the term to term. I'm just emphasizing really the appropriate way of saying like that. Okay, so that you can understand well what is an atom, what is a mole, what is a molecule, what is an ion, because there's a difference when you apply that already in a problem solving. Do not pattern all the time that, okay, you get the point. Okay, so 2 times 35.45, 35.45 times 2 mga palangga, 70.9 gram mole. Okay? Then that is 70.9. Okay, add pa rin ko siya sa calcium mga palangga. 70.9 plus 40, di ba? Di times naman mo siya. So 40, okay, ganun lang chuchu. Okay. So 40 plus 70.9 is gonna be 110.9. 110.9 gram moles is the molar mass of calcium chloride. So 110.9. Okay mga palangga, 110.9 grams. Then the mole will be in the numerator to cancel the grams of calcium chloride. So these are all calcium chloride, right? Now, this is the time you will utilize the 3 moles in your dissociation. Okay? So this is 3 moles of calcium chloride. Ganon. Di ba mga palangga? Okay. So if you have the mole here, and you have also the 3 moles of calcium chloride. You got the point? Ano siya may tabo. So pili mong answer ang yung hidalin na. Okay, so that you can determine the grams. Okay? Okay, atong i-subtract. Subtract, divide. Okay, so 40. Okay, 40 grams. 40 divided by 110.9 is equal to 0.360. Okay, mga palangga, kung hitad. Okay. Okay, so we have now times, ganon. So how many moles of calcium chloride, mga palangga? Okay, 3 moles of calcium chloride ions in every mole of calcium chloride. Okay? You get the point? Here is our decision chemical reaction. We interpret this in this way. In every chemical reaction, in every dissociation chemical reaction, we must interpret the way how it is being interpreted as peer scientists concerned in their contribution. How they explain in that manner, to, what do you want? Have an inference. How to do the interpretation very, very well according to their theories or postulates or theory, something like that. I will say, I have 3 moles of calcium chloride, the total ions. Say, I have the 1 mole of calcium chloride here, and the stoichiometric relationship of the calcium chloride is 1 mole, right? So in every 1 mole of calcium chloride, again, in every 1 mole of calcium chloride, you dissociate that, right? It will yield a total of 3 moles of ions of calcium chloride in solution. Meaning aqueous total ions of calcium chloride, not the solid itself, na wala pa siya mo-dissociate. You get the point? This 1 mole of calcium chloride is not yet dissociating. Okay. When you add the water, it's already dissociating. That's why you need to compute the total molecules ions during and after dissociation. Okay? Now you can cancel the number of 1 moles of calcium chloride here, 1 mole calcium chloride here. So now your total number of moles here, itong dalitan mga palangga. Okay? So ganun, makalibog siya no? Pero okay lang, tinang-tinangan siya ng mga okay. So 40 times 3 is equals to divided by 110.9. So it's gonna be 1.08 moles, 100.08 moles ions, okay, of calcium chloride. Okay. We consider the total number of ions as ganito because it's in the definition. Okay, colligative property, vapor pressure lowering is dependent to the concentration of molecules of solute or the ions. That's why we will not stop here. Number of moles in the computation basing on the molecular weight and not also in the chemical reaction. That's the reason. It's in the definition in the theory. Okay, it will be vague kasi if you will not try to follow this. Okay, so we have the 1.08. So put that here. Plus 1.08 moles of calcium chloride. Now determine the mole fraction of solvent na talaga siya. Okay, you get the point mga palangga? It's gonna be like that, ha? So I will tell you something also, the tricky part later. So 1.08 plus 33.30 34.38. Okay. 34.38. Okay, and we have also 33.30 divided by this one. Your idea, guys, mole fraction, mga kalangga, is always lesser than 1 because it's a fraction. Okay, it's point something 2 by 2 2. It will never be beyond 1 or else it will not be a fraction anymore. Okay, because a fraction or a point something multiplied by 100% will be equal to a certain figure. For example, if I have 0.25 times 100%, it will become 25%. Now, if it is more than 1, it will go beyond 100%. So it's not logical to have a more than 1 mole fraction by math alone. So sayop nakadaan. You are now in error if you obtain mole fraction more than 1. Here it's expected it's less than 1. All the time. Okay? That's a theory. You don't have to debate the theory. Okay, 33.30 divided by 34.38 is equals to 0.9685. Ganon. 0.9686 pala. 0.9686. So imagine a 0.686 mole fraction of water. Now I may explain. Okay, 0.9686 nearly to become 100%. Now, I could say in my problem that we are using pure solvent here. Pure, meaning highly concentrated. Because it is 0.98 close to 100%. Okay? If it reached to 90 plus, automatically that is concentrated. And you may say in your terminology that pure water or vapor pressure of the pure water or vapor pressure of the pure solvent. The adjective pure describes the type of water, how concentrated it is. Adjective describing something. Okay, so I describe the water that is really having that kind of property, which is pure. Okay? Like that. Another support theory, because this is at standard. Normally at standard, the water will become more pure at standard temperature. Theory. The more the temperature will not become standard, and then the more your water will have a lesser value of the purity or the concentration. What am the purity and concentration? So it will go up 50%, 40% like that. Okay? So if it is really meeting the standard temperature and pressure, so you will say, pure solvent. Ganon. Not only limited to water, but also all inorganic liquids or organic liquids. Okay? Walang lusot. Okay? You got the point? So it's gonna be the situation here. Now, if we have the mole fraction of solvent, which is 9.9686, substitute that in your original formula of your Wheel's law equation. Okay, I will erase other data here because there's not enough space in my whiteboard, very limited. I cannot expand my discussion very well. Okay, 0.9686. Ako na lang siya i-memorize mga palangga, di ba? Okay, mole fraction of solvent, 0.9686, then fraction, then no unit, because it is a ratio and a fraction, no unit. Okay, multiply with the vapor pressure of water, it's mentioned in the problem or not? Okay, here, vapor pressure of water is 23.8 torr. 23.8 torr. Then, we have now the vapor pressure of the solution equal to, okay, 0.9686 times 23.8 is equals to 23.05. 23.05 torr. Then if the problem will ask, what is the vapor pressure lowering in atmosphere? Then you have to convert. In bar, you have to convert. In mmHg, you have to convert. In PSI, you have to convert. In kilopascal, pascal, you have to convert. Because I taught you yesterday, the different standard units of pressures at sea level and at standard temperature and pressure conversion. Okay, you can do that. Like that, okay? Manipulation of the units only. Okay, so we have now the vapor pressure of your solution is equal to 23.5. Okay, Monisha. This is not yet the answer. Why? Look at the problem. What is the vapor pressure of solute in the solution? This is asking for solute. Now, if you stop here, you think this is correct, and you are now in the verge, or you are now in the mode of your actual examination in the future, you may tempt, or you may answer this automatically. Okay? Also, this will be declared in the questions, also in the choices A, like this A, B, C. And this 23.05 is in the letter A. This is also the usual mistakes of more examiners. Okay? And we will answer A because we get 23.05. But it's not. This is not the vapor pressure of the solute. How can we do this? Okay. Now take note. In our question instruction, the instructor also will not specify the vapor pressure of solute because it's always the formula it's being required to solve. This is the analysis already that comes out by instinct of the examinee. Instinct meaning nobody taught you to do that. It's your initiative to do that, how fast your IQ really is. Something like that. Okay, so I will teach you for this. Okay? Now, so it doesn't mention there in a specific topic of the colligative property how to compute for the vapor pressure of solute. Now, this topic also linked in the expression of the concentration. Do not think that if you are on the other topic, you will never apply the previous topics. It's understood you have to apply the previous topics, link that in your present topic, even though the instructors did not emphasize that to you. Because they are very, very, very wise. During prelims, midterms, and finals, they will find a problem that correlate in the past. Get the point? So that to calibrate the learning outcomes of the students, if you are really having the initiative or an effort to do your own self-review apart from his or her spoon-feed discussion at that time. Okay? That's the point. And that's the main reason that during finals, our scores are only small, like that, because we failed to connect that to our previous topic, in which it can still be used in the latest topic. Okay? That's why I advise to you also not to forget the past topics, and better not to focus on the present, but also you need to go advanced on the other topics so that you can have now a full maximization. You can maximize your own learning outcomes, even though the instructors and professors will not feed you. Okay? You get the point. You should be independent at all times. Okay? Something because the learning is for you, not for them. And you can use that in the real world after your education in your curriculum. And that's the best goal and objective. It's not really the grade. It's really how you apply that after in the real world, and that can save your life in the future. Like that, for example, if you mix acid and water, what will happen? It will explode. Something like that, for example. And then you don't have a fury, then you will be in injury. Okay? So things like it's being taught also in chemistry. When you mix an acid and water, whatever, so like that, it will explode. Something like that, because meaning to say, it is not additive to water. So read carefully the safety data sheets or the hazards rating of the chemicals before proceeding to your laboratory analysis techniques in your laboratory, something like that. Or if you know the theory already without reading the packaging instructions for the battle, then proceed. Okay, because the theory is really perfect already. But sometimes our memory fails, right? So you need to have to read the instructions properly of the battle of the chemical solvents. Usually in the laboratory of the university is always, or institution, whatever, or in school, having the instructions like that. 0.5 molarity of like blah blah blah, 25% sodium hydroxide, like that, and some of them are explosives, toxics, reactive, and then explosive. If you mix that with water, and if you don't have an idea, So that's why I told you it's not only the grades is your target when you go to school. It is how you apply in your day-to-day life. Okay? Whether you are in the school, outside, or even after your education. Okay? You get the point. Okay? Because chemicals are very, very deadly. Really. Okay? It's very, very deadly. Okay? Most of them are toxic. Okay? Reactive, radioactive. That can cause cancers and carcinogens especially can cause cancers. Okay? Like that. You get way back now here. So we have the vapor pressure of the solution is 23.05. This is nothing the answer. Now we manipulate how to solve the vapor pressure of the solution. Now going back to the expression of the concentration in the topic of percentage by mass, percentage by volume, or let's connect this to the topic of ideal gas solutions like that, okay? So we say that, for example, the vapor pressure of the solution, okay, is equal to the vapor pressure of solute plus the vapor pressure of solvent. Okay, now you have the vapor pressure of solution in which you already computed 23.05. So substitute that here, we have vapor of solution 23.05. Then vapor pressure of solute in which you are asked, put that as an X. Or anything variable, it doesn't matter as long as you understand what you are trying to find. Okay, so vapor pressure of solute, okay, this P solute, okay, plus vapor pressure of the pure solvent in which you mentioned in the problem, which is 23.8. Now, by basic math, elementary level, grade school level, or primary level of education, you can add very easy for this. X plus 23.8 is equal to 23.5, so X will become 23.8 minus 23.05. Ganun, diba siya? Hindi siya natagong mga panagat, right? Okay? Ganon. Okay. So, math. Ganon siya guys. Math rin siya guys. Okay. So, 23.05 minus 23.8. Ganon. So, 23.8 ganon mga palanggat minus 23.08 is equals to, okay, 0.72. Okay. Now, take note mga palangga. Okay. Take note. Okay. The answer will be 0.72. Okay. 0.72, very small. Okay. This is your vapor pressure of the solute. Take note mga palangga. Okay. 0.72. Why it's very less? Because that is only the difference of the pressure between the two. Okay? The pressure of the vapor pressure of the solution and the vapor pressure of the solvent. Of course, the difference is very small. You get the point. Okay? So you can say that also as change in pressure is equal to the vapor pressure of the solute. Directly without question. Okay, vapor pressure of the solute. And this is the reason why some books, some references use delta P because of this concept. Okay, it's not discussed there, but I researched by my own why it become like that. Okay, so the change in pressure or the vapor pressure change or the difference in vapor pressure between the solution and the solvent will be just equal to the vapor pressure of the solute. Okay, which is equal to 0.72 torr. Wow. So vapor pressure of the solute is 0.72 torr. Ganon. So imagine the choices is very small, right? And you will answer 23.05. So problem, that's too far. Okay, get the point? So we can say here, manipulate again, change this to delta P. This vapor pressure of the solution, you will say delta P. Okay, pareho naman siya, change in vapor pressure and difference in the vapor pressure between the solution and the solvent. Okay, that's very clear. Okay, now that's our answer, 0.72 torr. Okay, now if the question was what is in kilopascal, I'm going to convert the torr to kilopascal. 760 torr is equal to 101,325 Pascal. And then you can have Pascal as a unit of pressure. Something like you can manipulate if you have already the conversion factors. Okay? Any questions so far? Okay, now I'll also give you a clue. Okay. In this kind of problem, The important is the total number of ions of your solute. Okay? Mag-note ka rin, no? No, ganon. No. So that ma-perfect mo in the examination if the topic is like this. Okay? So note, okay. Total number of moles ions, okay, will be considered here. Okay, not the number of moles in the chemical reaction and not the number of moles basing on the data, but in the total moles basing on the dissociation reaction. Okay, that's the first. Ganon. Now take note. Okay, if this is not a compound, if this is a compound that has no subscript, okay, for example, sodium hydroxide, it doesn't matter because the subscript matter here when you add something. Example, sodium hydroxide, you dissociate that to water, right? An aqueous solution. It will just become Na positive plus OH negative, right? You get the point? So it doesn't matter because the charges are not 2. There's no subscript 2 here. So you will just say 1 plus 1 ganon. So that's 2. You get the point? Mga palangga, mora siya mabatong tumos ayos na siya. Okay? Kasi may tabo. Okay? Ganon. You get the point? So dahil man din ang kasunod na may tuloy-ari. Okay? So dissociate mo na siya factor. Unless 1 is parang irrelevant na siya. The same as nothing in chemistry. Okay? Like that. Like the sodium hydroxide, there's no number of mole. Then if you put 2, lahi na siya. Okay? That's the point there. Okay? So, some are, for example, I will give you the others. Okay? For example, aluminum sulfate. Aluminum sulfate. Ganon, chuba. Sodium phosphate. Ganon. Like that. So, there are a lot of subscript, right? So, it will matter now the total moles ions. Total moles ions in your dissociation, not your chemical reaction, ha? Okay? Ganon. Okay. Okay? So, sometimes it will change like this. 50 grams of sodium phosphate is dissolved in 600 and they change only the compound. Okay? But it matters only in the dissociation chuba-chuchu, in your mole fraction computation of solvent. Okay? And sometimes also, okay, enough for that. Sometimes also, guys, your compound also is also a liquid. For example, I will say 50 grams of ethanol is mixed in 600 ml of water. Now, in this kind of problem, you cannot judge easily which is the solvent and which is the solute. How can you identify that? How can you identify that? Now, go back to the percentage by mass and percentage by volume and check it out. Which among them have a higher percentage? That would be your solvent. Because by theory, the solvent should always be in higher amount compared to solute. Okay, decide first because in your formula, there's solvent here, mole fraction of solvent, plus vapor pressure of solvent. Then if you use the wrong solvent, then you will automatically wrong in the case of all our liquid, right? And sanay, we are just used always every time in this problem that our pure solvent is always water. What if we mix water and, for example, acetone, and then it will happen that the solvent is the acetone. Nga. That's why we need to compute for the percentage by mass. Okay, we are used to manggod sa mga problems, sample problems, that our solvent is always water. What if all compounds are being mixed are all liquids? Meaning to say, a homogeneous mixture. Okay? So, you should compute first the percentage by mass or percentage by volume. Now, if there is concentration given, then refer to the concentration directly. Okay, if it is point 5 molarity, then conformity, so through concentration you can also determine. But better solve this one, it's more good. Okay? Because most of these type of problem will never mention also the normality, the modality, like this in this particular topic, especially the vapor pressure lowering of the solution and the Raoults law. It's not all the time we'll mention the molality, normality, molarity, diba? No, no. Maybe it can, but as what I've observed, it's not usually encountered. So that's why you need to focus the percentage by base and percentage by volume. Okay? Any questions so far, mga kalangga? Nothing? Okay. It's very clear. So this is all about vapor pressure lowering of the solution and Raoults law. Okay. So now if the problem of the future, guys, okay, I give this topic this because in the board examination, this is not my highest score. Actually, my highest score is chemical engineering talaga siya. My major. Really. And I was shocked also because I love this coverage than chemical engineering. Okay? And of course, obviously, my general engineering is low compared to the field. As I told you, I'm not good in math. It will really, it will really be matching your performance in areas you are weak. Something like that. Okay? So when you add the 3 scores, then you will pass something like that. And when you compare the 3 coverage, oh my God, the general engineering is lesser to my chemical engineering, and the coverage that I like the most, which is the physical and chemical principles, concepts and theories are second, and the chemical engineering is higher. Ang nakakaloka. Okay? I was shocked for that. Okay? But anyhow, maybe I got the correct answers more than the physical and chemical principles, right? Because unit operations are very also difficult. I was just shocked at the time. Get the point? Okay, wala siya mga palangga. If you have some questions, you can ask now. And you can comment, like, and share this video if you want also for educational purpose only, not for commercialization, nor for competition. Who among us are intelligent over the other? No, it's not like that. This is for educational purposes. A guide, not really a requirement, a guide only. Okay, something like that. And you can subscribe my YT channel if you want. Okay, and then you can click the bell notification from some newest updates that I am a singer. Welcome to my science world. General chemistry lectures and a lot of chemistry chuba chuchu. Bye bye, God bless everybody. I'm planning also to vlog physics. Okay, I think after 2 months. Physics and then a little bit higher, unit operation, until such time, magunaw man ang mundo. Dumugo man ang ilong ni June. So, that's my content. Because if I will sing, copyright will be there. I cannot gain revenues. That's why I need to do this. Apart from sharing the knowledge and information, academic information. Okay? Like that. Okay, thank you so much, guys. And this is also the way I can relate the most, rather than relating other topics in which I am not familiar with, right? And I'm not used to it. Okay, especially politics, like sports, whatever, money management. Okay, it's not really my expertise about that. Okay, so that's why. Okay, thank you so much. Bye bye, God bless everybody. Diba? Luto-luto isa ko ka maumuluto. Okay. You get the point? So there's a lot of topics actually, guys. And explore is not also not good. City is very far. We are in the remote area. How can I go to all the time in the city and make some exploration, adventure? No. It's time wasting also and money wasting. Like that, okay? So that's why I prefer to use this kind of content. Okay, actually there's a lot, right? Going to the different, places or whatever, okay, but it's not really my preference. That's why. God bless everybody. Bye-bye.